So first, before getting into the ASM, first we have to understand few terms in here about the local traffic. Local traffic objects and their behavior. Okay, and the main that as we consider the local traffic manager, LTM, as I told, it's a module which is a very basic module from F5 and also called as a load balance. Okay. The first and foremost thing is your LTM, or the load balancer big IP, is a basically it works as a proxy, specifically reverse proxy. Why? Because your client is accessing applications and this proxy is at the server end. And in the back, behind this, you are having the LTM, and behind this LTM, you are having the server. So this works as a reverse proxy. Okay. When we consider normally the traffic flow with the LTM, your client would your client would initiate a TCP connection to an IP address that is configured on the big IP. And then your big IP responds for that client's TCP connection. Connection is established. Once it is successful, then your F5 will forward the connection to the backend server. SYNAC acknowledgement. This is reverse proxy because your client's TCP connection or the client's request is not straight away going to the backend server, but your big IP box in here is interrupting it. It is stopping it. It is saying, no, you are not allowed to go all the way back. You have to wait for my instructions. Okay, so that's where it is called as a reverse proxy. So technically, when a connection is initiated, or when your client, end user client, is accessing an application, and if there is a big IP box in between with LTM, then there are technically two sessions, two connections from the big IP's perspective. One is the client side, and the other is server side. You got it?
Yeah.
But this doesn't mean that it behaves this way always. No. It can also be a transparent device in some cases. You can, if you want it to be, if you want the big IP to behave as a transparent device, you can. Answer is you can. Okay. But by default, it is a proxy. And this is proxy because your client never knows that there is a device in between. He still thinks that he is speaking to the server directly. Server still thinks that he is speaking to the client directly, but making them bluff, there is a device in between, and he is behaving. Okay, so at a high level overview, this is the a default and normal traffic flow. Okay, but if we get into details here, that's where our objects come into picture. In order to make this happen, in order to make the end user client request PIP first, PIP responds to the client on a successful TCP connection, then F5 will forward the connection to the backend server. In order to make this happen, the local traffic objects, we have to understand the local traffic objects here. The first object is virtual server. The first object is virtual server. Now, what is a virtual server? By default, yes. By default, BGP is a traffic denying device. It doesn't accept any traffic, any connections, until unless something is configured on it. It's same like your firewall. You have Fortinet's, checkpoints, Palo Altos. These are by default traffic denying devices, isn't it?
Yes.
Positive security model. They've always followed the positive security model. They deny everything. Whatever you think, whatever the network admin thinks that yes, this is positive and this can pass through the firewall, you have to explicitly permit it, and then the traffic goes through the firewall. In the same way, on the big IP, you by default it denies the traffic. It's like it has some default denying rule. Okay, and again, specifically, you will not be able to see that rule, but the behavior, the architecture is designed like that you deny the traffic. Now, in order to permit the traffic through the big IP, maybe it is going to LTM. Yeah, that's what basically it needs. But in order to permit the traffic, for an application, we have to configure a virtual server on the big IP. Which is a listening object. So we basically define this as a listening object. Listening object is, let's say you have configured the virtual server like 172.16.20.10 or 20.100 on port number 443. This is your virtual server you have defined. In the destination IP, you have configured 20.100, and the destination port, you have configured port number 443. Now, what does this mean is, if there is a client coming, there is a client request coming in, he should, the destination IP of the packet, the destination port of the packet should be 172.16.20.100, and the port should be port number 443. Then only your client's request would be going through the big IP. It will be load balanced, and it will be going to the backend server. Understand this?
Yeah.
So that's what the listening is. He is listening on this IP address and he's listening on this port number. So if there is any end user, if there is any packet coming for this destination and the port number, then only your big API will permit the traffic through. If not, it will be denied. So he's listening. Technically, he's listening on the traffic. He's listening. Yeah. Is there anyone coming for 20.100 on port number 443? Yes. Only you are allowed. Okay. If something beyond that, let's say some packet is reaching the big IP 172.16.20.101 on 443, big IP says no, I am allowing the traffic only for 100.443, but you are for 101.443, so you are denied. So he's listening. Okay. Now, since we are speaking about the LTM, on the LTM, the listening object, we call it as a virtual server, but this may vary with the modules. Let's say if you are going for DNS, FI DNS, your FI DNS also has a listening object, same like your virtual server, but we call it as listener, not the virtual server, but we call it as listener. Okay, the purpose is same all about it. Altogether, the purpose is same. The purpose of the virtual server in LTM and the purpose of the listener in the DNS is altogether the same, but the name is different. That's it. Okay. So the takeaway is traffic with the destination as virtual server IP and port will only be permitted through the big IP other than that traffic would be denied. Got it right? What is a virtual server?
Yeah.
Okay. Now, yes, now that's good. Now we have a virtual server. So we have decided what should be the virtual server IP address plus port number, and we have a virtual server now. But how do we decide the pool member? To which pool does the traffic go? How do we configure that? So that's where pool comes into picture. Now what is a pool? A pool is group of servers who are running the same application. Group of servers, right? Now here servers means, as you said, yes, pool members or IP plus port, whatever it is called as port number, right? Yeah. So pool is a group of servers. You bind them all together so that you can call that single pool with a virtual server instead of mapping all the pool members individually. You got it right?
Yeah.
Yeah. So instead of mapping each server with its IP and port to the virtual server directly, what you do is in between you configure a pool. You will configure all the pool members in the pool and you will call the central pool, the group of pool members, pool directly with the virtual server. So you avoid the confusion at the virtual server level. Okay, but a very simple takeaway here is who are running the same application. Who are running the same application? Let's say I'm having two servers. 12.1 with port number 80. 12.2 port number 8080. Remember, if the port number differs, FI doesn't care. FI doesn't care. What you have to make sure is, yes, 12.1 is responding for port number 80 and it is responding with a web page. So it is running web application on port number 80. 12.2 is running the web application as 12.1 did, but port number is different. That's good. FI says, no, I'm okay with that. Okay, so there's a misconception here. People understand that pool is a group of servers running the same port number or listening on the same port number. No, those are running on the same application, but listening on multiple port numbers, different port numbers. Right? At the end of the day, if the request is forwarded to 12.1 on port number 80, it should give the web page. If the request is sent to 12.2 on port number 8080, it should also send the web page. This is the only requirement. That's what it called as who are running the same application, no matter what the port number they are listening on. It only matters if it is responding, all the servers are responding with the same web page or not. That's